Good morning. And good morning. Welcome to our third lecture for Microeconomics 1P91. For those of you who I haven't met in person, so if you couldn't attend last week's in-person lecture, or if you're not able to attend tomorrow's lecture, I just figured out how to do this using Snagit to capture my screen with the video. So I just want to say hi, put a face to the name. So for those of you I haven't met in person, my name is Jeff Black, and I am your instructor for this class. Today we're going to talk about the market forces for supply and demand, and then ultimately try and understand equilibrium price and quantity, and how we derive that using a demand and a supply schedule. Okay, so that's what we're going to do today. Before we get into that though, I want to draw your attention to a few things. So number one, this is where we're at today. These slides will be on Sakai, so you can view them without my narration. You can just go through at your own pace. But I'm going to go through these slides, 55 slides. This lecture is going to double down for both the Monday and Thursday, so it'll be an extended lecture, just like I did last week. So if you can't make it to lecture tomorrow, okay, like I'm recording this, it's Sunday at 4. If you can't make it to lecture tomorrow, everything I'm going to discuss is in this video, okay? But I'm not going to only post the second half of it for Thursday. I'm going to post the whole thing. So everything I discussed today, or everything I discuss in lecture tomorrow, is included in this video, as well as the Thursday lecture, right? All we need to get through, if we look at our outline, is, so here we are, right? The week of September 20th through 23rd. We just have chapter 4. So it's the market forces of supply and demand. So that's what we got to do for the week. So we've got 3 hours or two 1.5 hour sections. I'm pretty confident I can knock it off in under 2 hours. So that's what I'm going to attempt to do today in this presentation. Tomorrow I'll lecture for the full hour in a bit and get through as much as I can, but whatever I don't, you can just reference this video, okay? You'll notice that you have your first tutorial this week. I've mentioned this several times now. And assignment 1 and 2 are due. Okay, assignment 1, you're just going to take it up. Your TA is going to go through the questions, provide you with the answers. You can take them down if you think you need to. But assignment 2, you should have uploaded to Sakai, right, using Dropbox. So I'd like you to upload your assignment answers to Dropbox, and they are due before your scheduled tutorial. So if your tutorial is tomorrow at, so the first one is Tongs, tutorial 5, starts at 10. That means you have to have uploaded assignment 2 to your Dropbox folder before 10. If it comes in at like noon or later, or even 10:30, we're not going to count it. It has to be uploaded before your scheduled tutorial, okay? So that goes for all tutorials. So if you don't know where your tutorial is, it's on the outline, right? These are the numbers. You've registered into one. These are the days, the times, and the rooms, okay? And these are your TAs, and I've also given you all of their emails. So if you have any concerns about tutorial, you want to network with your TAs. I don't micromanage tutorials, okay? So the TAs look after their sections. So if you have some kind of extenuating circumstance where there's an issue with you submitting your assignment, or participating with attendance for tutorial, or if you have questions about the assignment, your TAs are the contact person, okay? Like there's 385 kids in the class. I can't have 385 kids asking me about the assignment. Your TAs have the answer keys. They've been through the problems. So that is your contact person. So if there's a question about the assignment, reach out to your TA. Hey, listen, can you help me with this or that? And they'll do their best to do it. So this week, your TAs will obviously introduce themselves to you, and they'll offer some office time. So they'll make themselves available for like extra help or office time for at least 1 hour a week. So they'll communicate that to you. It may be done online. So each TA has an activated Teams channel for their section, so you should be getting an invite for that. Or possibly they'll do it in person on campus, okay? So tutorials begin this week. And this is what we're going to cover. Okay, so this week we're doing Chapter 4, the market forces of supply and demand. Next week we're going to talk about elasticity, right? This is a really cool, fun topic. I think you're going to dig it. It's really novel for economics, especially microeconomics. Okay, and then you'll have assignment 3 due. Okay, so that brings me to my next point. So on our Sakai page, I've changed it up a little bit. So you notice in resources I have assignment 1, assignment 2, and then the lecture slides for last week, the video for chapters 1 through 3, updated course line. Eventually this resource tab is going to get too inundated with information. So I'm going to use this assignment feature. So if you click on assignments, okay, I've put assignment 3 up. Okay, so it's under assignments. Everybody has access to this through their Sakai page, but just rather than assignments being posted in resources, they're going to be found in assignments. Okay, so assignment 3 is here. So this deals with supply and demand. It's 8 questions. The last 2, you need to have a calculator. There's some math involved. Okay, it's out of 20, and your TA will mark it and then put the your grade on Sakai, okay, in gradebook. So eventually you'll be able to go to, I'm not going to pull it up because I don't want to show everyone's contact information, but gradebook, if you click on gradebook, it'll showcase your grades, and so you will, by this time next week, have a grade for assignment 2. In the tutorial following that, okay, so tutorial number 2, you will hand in assignment 3 and your TA will take up assignment 2. So we'll always be 1 week behind, okay? So if that didn't sink in last lecture, hopefully now that you're actually in tutorial, it'll make more sense. All right, and we're going to go right up to chapter 6, supply, demand, government policies. So that will be a lecture on the Monday, and then your midterm is on the 7th, the Thursday. Okay, so it speeds up a little bit, right? We'll have a lecture Monday, and then boom, you got a midterm on the 7th, chapters 1 through 6. Okay, I'll talk more about the midterm as we get closer to it, but you need to register to MindTap. So right now, as it stands, I just checked, only 250 of you have set up an account through MindTap. Okay, everybody has to. There's no exceptions. You need to. You can't write either midterm or the final unless you're on MindTap. Okay, and that requires you to buy one option of the textbook. Again, it's your preference if you just want the digital, if you want the hardcover, the leaflet, like the loose leaflet, whatever your preference. Either way, you'll get a course code once you make the purchase, and that will enable you to register an account with MindTap. Again, use your given name, right? That appears on your student card, first and last, and your Brock email. I've had a few students who didn't get that information and they had already set up a MindTap account. As long as it's your name, I'll be able to identify you. But MindTap and Sakai are totally separate. They're not integrated. So I have to manually enter your grades into Gradebook. So I need to know who you are. So if you used an alias, I won't be able to identify you. So as long as it's your name and I can match it on Sakai, you're fine. But anybody who hasn't done it yet, make sure you use your given first and last name and your Brock email. That way I can triangulate who you are using a variety of options. Okay. So I just wanted to go through this quickly so everybody knows where we're at and where we're going. So next week, I'll do the same thing. I'll do an online lecture, like a Snagit lecture on elasticity and its application. That will be good for both the Monday and Thursday lecture. I will, however, deliver an in-person lecture on the Monday. Okay. So that would be on the 27th. And I'll do it the same for chapter 6. I'll deliver an in-person, and that will only cover chapter 6. So we're going to get it done in one shot. Okay, so if you have any questions about the way the class is organized, course composition, that sort of thing, don't be shy. You can reach out to me for that kind of information. But if it's something specific to your assignment or tutorial, please reach out to your TA. And if you already know, for example, that you have a conflict with either midterm, right, because the dates are posted right here. If you know that you have a varsity event or some other extenuating circumstance that will prevent you from being able to write, you need to communicate that to Indra, who's our course coordinator. And I hate scrolling up so fast because I know it's hard on your eyes, but her contact info is right here. So you email her. If you have any problem with making yourself available for the midterms, as long as it's reasonable and you have documentation, we can either wait a midterm in one way or another so that it doesn't penalize you. Okay, but I just like to go over the outline, make sure everybody knows what our objectives are and the order of events. Okay, so again, if you have any questions, don't hesitate. All right. So again, the assignment is up. It's under assignments. Yeah, I think that's all I really need to talk about. Let me just quickly reference my notes. Oh, I did get a bunch of emails about MindTap. So there are all kinds of practice tools on MindTap. So you can write practice quizzes. There are practice assignments. There's all kinds of extra information. None of that counts, okay? None of it counts toward your grade. That's all practice. That's just done independently through MindTap. The only things that I use in MindTap for your grade are the midterms and the exam, okay? So to make it crystal clear, anything you do on there that is not a midterm or an exam is for practice only. I encourage you to do the quizzes and some of the assignments and watch the videos and utilize all of the supplemental information that is there, but it doesn't count, okay? But I should point out, the quizzes that are on MindTap, they draw questions from a pool of multiple choice options. And the questions that I use for your midterm, 1 and 2, as well as the exam, come from the same pool. So, I mean, there's thousands of them. There's about 1,000 questions, I think, for the text. Actually more. I think there's 2,500. So you may see the same question on a midterm or an exam that you did in a practice quiz or assignment. So it's not in vain. You could get something out of it. Okay? All right. So enough about the course. Let's now get into our lecture. And this is some pretty cool stuff. I think you're going to like it. This is like really practical, relevant stuff. Okay? And if you remember, last lecture, the one I delivered in person, and I also did a video, I really tried to bestow upon you this development of the enlightened man, of Adam Smith, and kind of like the market forces and how it's self-regulating, this invisible hand, right? This is one of those 10 principles of economics. And this is good for both micro and macro. So unfortunately, if you're taking micro and macro simultaneously, if you are one of the students who are doing both, this is going to be an overlap because, like, fundamentally, you can't understand micro or macro unless we do the core principles and we really flesh out the market forces of supply and demand. So my apologies if you're doing both. This is going to seem a little bit monotonous because you've been through this already, but most of you, I would say 95% of you, are doing one or the other. You're doing them independently, so we have to go through it. So again, last lecture we talked a lot about Adam Smith, the market forces, invisible hand, right? And near the end we talked about gains from trade, and we tried to map out some scenarios with Frank and Rose. So hopefully that made sense, and that's fair game for your midterm. We're going to switch gears though now, and we're going to talk specifically about the market forces of supply and demand. So we're going to drill down and really try and understand where this concept of an equilibrium pricing quantity comes from. Okay? So, the first thing to note are the two forces, right? Namely, supply and demand. And this is pretty intuitive, right? When you think supply is coming from a producer, right? It's somebody supplying something. So whether it's a firm or an individual or a small business, it's the supply of something, right? They were either manufacturing it or producing it. And one thing you should be aware of is it doesn't have to be a good, right? It could be a service. There is a supply for services as well, right? Being a teacher is a service. Being a barber is a service. So there is a supply of barbers and teachers and electricians and plumbers and so on. Those are services. There's a demand for those, right? And a demand not just for services, but a demand for goods and services. So it could be a demand for beer, or a demand for pop, a demand for cell phones, right? So the market is comprised of two principal forces, supply and demand. And their interaction influences the price. And it's that price that really acts as an indicator, right, for competing forces. So maybe you'll get more supply if the price is really high, because that warrants more profit, right? And as we'll learn, profit is just simply price times quantity, or total revenue, minus total cost. So how much are you getting in revenue less what does it cost? That equals profit. But in that equation, we said price. So if price is higher, then it's likely profit will be higher. Okay. But in any event, these are the kind of like the forces at play that I briefly touched on when I mentioned Adam Smith's invisible hand in this self-regulating economy that is really like an enlightenment for this economic man, right? Or this economic man is enlightened with this reality that the economy can self-regulate. We don't need a top-down authoritarian director guiding the economy. It does so independently with these market forces that we're really going to investigate. So we have supply and demand, and these are two words most often used by economists. So again, supply represents the supply of a good or service, and demand represents the demand. They're what make market economies work. Okay, so we talked about what a market economy is. These are what make it work. You need both a supply and demand. They determine the quantity of goods, the quantity of good produced and its price that it's sold. Okay, so the supply of a good and the demand for that good determine the price of it. Obviously, if there's a lot of something and a little demand, the price will be low. But if there is a really high demand for something and it's in limited quantity, the price will be high. Okay, and we're going to graph this and really try to understand these forces. Now, we can use this, right, if we want to understand how any event or policy will affect the economy. Okay, so we can do this at a macro level or even at a micro level, right? And that means you have to think about how the policy or the directive, whatever the action is, how it will affect supply and demand. Okay. One thing that's really critical is understanding that supply and demand refers to the behavior of people as they interact with one another. Okay, so again, this is a social science, and so it involves the analysis of human beings, right? And human beings, they have behavior, right? They interact and change based on information. Okay, it's not an exact science. And remember, we said there are some assumptions that we need to be mindful of, right? That when we talk about the behavior of people and how they interact in a competitive market, we need to assume that these people are rational, self-interested agents. Okay, they make decisions matter-of-factly, right? Their decisions aren't impulsive. They're not reactive. They're not guided by any kind of supernatural or outside forces. They're making decisions rationally that advance their own personal self-interest. Okay, so that's critical. Rational, self-interested agents. So whenever we talk about the behavior of people and how they interact, especially in a competitive market, we need to do so with the understanding or assumption that they are rational and self-interested agents. Okay. So what is a market exactly, right? So we alluded to it last lecture, but basically, a market is a group of buyers and sellers of a particular good or service. Okay, so just to reiterate, there's differences between goods and services. Goods are things that you can actually like produce. They're tangible, right? You can pick it up, you can touch it, you can throw it, you can change it. It's a good. Okay, so there's all kinds of goods that are in markets. And then there are services, right? So when we look at a market, in this class, we're going to look at a particular good or service. So we're not going to look at the aggregate, all goods and services. We're going to focus in on like one good or service. So we could look at the market for apples, right? So we could have a farmer's market with a whole bunch of apples that are producing apples. So those would be the sellers. And then we'd have a whole bunch of people, right? Like citizens who want to buy apples. So we have a whole bunch of buyers and a whole bunch of sellers. Okay, so the buyers as a group determine the demand, and the sellers as a group determine the supply. Okay, so they're two separate forces. The buyers are the ones who determine the demand for the good, and that's a function of, hey, like my preference, my budget, my allocation of resources. Do I really want apples? And that will determine if I'm going to buy, and if I do, then that puts pressure on the demand for apples. Okay, and clearly the price is going to be indicative of whether or not I want to buy more or less apples. If apples are really, really expensive, my demand is probably going to be less. And if apples are really cheap, my demand will likely be much more. And similarly, you have sellers for apples. So these would be the farmers. And obviously, if the price of apples is really high, then the farmers are going to be inclined to supply more. So again, the price is that indicator. But the takeaway here is that the sellers are the ones supplying the product. So whether it's the firm, the farmer, the small business, whatever the case may be, but that would be representative of the supply curve, okay, or the supply force. So market has to have both of these in play, okay? If you don't have a lot of sellers, like let's say there isn't a group of sellers, well, this would be what we call a monopoly. So that's not a market anymore, right? It's a monopolistic market where you have one buyer. Or sorry, not one buyer, one seller, right? You could have an oligopoly where it's only a few sellers, right? So if you look at like space exploration or travel, like there's really three big companies right now: Blue Origin, Virgin Galactic, and SpaceX. It's kind of, they have like an oligopoly. Or you look at like social media, there's, you know, Twitter, Facebook, Instagram. They kind of have a lock on that market. So in order for it to be competitive, we need a lot of buyers and a lot of sellers. So what I was just trying to demonstrate there was if you only have one or two, it's not a competitive market. You need competition for this to actually work, for it to be a proper market. Okay. So again, markets take many forms, right? Like a highly organized market would be one for agricultural commodities, right? Like, because there's so many moving parts, it's highly organized. You have to plan, right? You can't just like grow apples overnight. They don't just pop up. There's a lot involved, so it's a highly organized market. A lot of time, a lot of indicators that are incentivizing farmers to enter or exit a market, and so it's considered much more organized. Something less organized would be the market for ice cream in a small town, right? That's predicated on so many variables like the weather, the population, the time of year, the time during the week, right? So it's a little bit less organized. It's not as streamlined. It's kind of just ad hoc, right? It's much more reactive versus something that's more planned, right? So we really need to dive down or drill down into this notion of competition, right? So we said markets, in order for them to exist, there needs to be competition. So a competitive market is a market in which there are many buyers and many sellers, right? And the reason for that is not one seller or buyer can influence the market price, okay? So just let that sink in. In order for it to be a competitive market, you need a lot of buyers and sellers. And the reason for that condition is because there are so many buyers and sellers, not one buyer or seller can influence the price independently. Okay? So that would be a condition necessary for a competitive market. Because if you had one seller that was really big and really dominant, well, they could influence the price simply by their own actions. Okay, so then it's not really as competitive as it should be. They have an edge, right? If they have a dominant market share, then they could influence the price solely by their actions, and we don't want that in a competitive market. In fact, in a perfectly competitive market, buyers and sellers each kind of operate on the same basis. They all have the same market share, right? That would be a perfectly competitive market. But in order for there to be a truly competitive market, you need a lot of buyers and a lot of sellers, and there's no one buyer or no one seller that's big enough to influence the price, right? So that way, price and quantity are always determined by all buyers and all sellers as they interact in the marketplace. Okay, I hope that makes sense. Because if you think about like a really big firm, so think about telecommunications, Bell, for example. That is not a competitive market, right? That's more of an oligopolistic market because you really only have like Bell, Rogers, Huawei. I think there's only a handful of providers, and they're not all on the same footing. Like, you know, some like Bell would be like a dominant player, and what that means in the market would be like Bell could slash its prices, right? Or it could really ramp up its production of something, and it could independently change the market price of phones, right? Or the market price of phone plans because they're so large. And so that really isn't a good example of a competitive market because there is like a disequilibrium of range in terms of influence on the price of a good or a service. Okay, so you want everyone to kind of be equal. You want lots of buyers and you want lots of sellers. Okay, now the perfect example of this, and I've mentioned this previously, is that in economics we tend to really oversimplify, and we tear away like all the layers of the onion to get to like the core concept, right? Like remember when we talked about the production possibility frontier, and we said like this is a really simple example, right? Like typically there's no one firm that only produces two things or can produce two things, and we want to look at the way it allocates resources to come up with the different combinations of production. Like it's a really oversimplification. And we can do the same thing cognitively with thinking about a market. And we can say, like, what's the absolute simplest distillation of what a market could be? And we'll say, what would be a perfectly competitive market? And that perfectly competitive market is the model we're going to operate from. We're going to say, yes, there are definitely many buyers and many sellers. Okay, so then we dodge the problem of one firm actually having influence over the price by way of how much they're going to supply. And we also dodge the problem of one buyer influencing the price because they have enough influence to do so with their demand. So we nullify that problem. We're also going to assume that in a perfectly competitive market, the goods or services that are being provided, I should say the good or the service that is being provided is the exact same. So there's no differentiation between goods. Okay, So this is a condition necessary for a perfectly competitive market. No product differentiation. Goods offered, so it really should read goods or services offered for sale are all exactly the same. Again, buyers and sellers are so numerous that not a single buyer or a single seller can influence the price. That kind of leads to this notion that buyers and sellers are price takers. They don't get to influence the price. They just simply take it. It's the market that actually assigns the price through these forces of supply and demand. Okay? The market determines the price, not a buyer or a seller. The buyers and the sellers are simply price takers. That's what we want, right? We want them to be price takers. We don't want them to be able to arbitrarily, through their own actions, influence the price. We want them to be totally independent. Okay. Another condition that's not listed here, let me just check, maybe it is that we assume that buyers and sellers have no barrier to enter or penalty to exit. Right. So in order for a market to be considered perfectly competitive, this would be yet another condition. It's not listed here on my slide, but you should take note of it. That buyers and sellers face no penalty to enter or exit the market. In other words, there's no fee if you want to be a seller of a good or service. You don't have to pay anything to join the market, okay? To get like a potential to sell that good. There's no fee for you to join the market, okay? So there's no barrier to enter. You can just simply enter the market freely and sell whatever it is that the market is offering. And similarly, there's no penalty for you to exit. So if you want to get out, you don't have to pay a penalty. Okay. At the market price, we also note that buyers can buy all they want and sellers can sell all they want. So there's no, like as the supply is drained down, the price doesn't go up. Or as demand ramps up, the price goes up. It's just assuming at that price it's infinite. There's an infinite amount of demand and an infinite amount of supply. So buyers can buy all they want and sellers can sell all they want at that price. So the forces of supply and demand don't actually influence the price by them buying too much or demanding too much. Okay? That makes sense? Buyers can buy all they want at that price. So as they buy it, as buyers buy, it doesn't affect the price, right? It doesn't affect the demand curve. They can buy all they want at that price. And sellers can sell all they want. Okay, so they're not limited. Like let's say if it was the market for apples again, I mean obviously there's only, in real life, there's only so many apples that can be grown. And so the supply would be reduced every time a transaction is made, but we're going to assume sellers can sell all they want at that price. Okay. Now, obviously, not all goods and services are sold in a perfectly competitive market, right? In fact, hardly any goods and services. You'd be hard-pressed to find one that are sold in a perfectly competitive market. Most fall into some range between a perfectly competitive market on the one end or at one extreme and a monopolistic market on the other. So that's kind of like the spectrum. You have a perfectly competitive market on the one hand and a monopoly on the other. A monopoly means like mono, like one seller. Okay. Versus a perfectly competitive market has many sellers. So most markets operate somewhere in between those two goalposts, right? You either have, like as you move down the monopolistic side, you go from monopoly to an oligopoly to a cartel, and then you start to get closer to this idea of a perfectly competitive market, right? You go through like just a competitive market and then a perfectly competitive market. Okay, so we're just trying to set the stage for the different kinds of markets, the extremes, and the conditions that apply to those extremes. Okay. So this is just reiterating my point. Most markets fall between this range of perfectly competitive versus a monopoly. Okay, I'm just going to take a drink. Before I go on, don't forget that like tomorrow or today, so I'm recording this Sunday, but you're likely watching it Monday, Election Day. So if you haven't voted yet, you should. Okay, so let's now look at one curve in particular. So we're going to do this one at a time. Let's look at the demand curve first and try and understand where it comes from, how it's graphed, and then we'll do the same for supply. And then we'll have them overlap, right? We'll apply these two competing forces onto one graph, and that will enable us to look at this one really special point on the graph. And that's where these two curves intersect, okay? So let's first look at the demand curve, okay? And I think demand is easier to relate to because we are consumers, right? It's not likely that any of you are producers. I mean, maybe you have a job where you make something or you're part of that. Or, I don't know, maybe you have a small hobby or craft that you produce. But all of us are consumers. So we have a demand for things, right? And so we want so many movie tickets, or we want this many pairs of shoes or jackets or a laptop, right? We have a demand. So it's easy to understand, I think, or relate to the demand curve. And the one thing we need to be clear of is there's quantity demanded. So this is the amount of a good that buyers are willing and able to purchase. Okay, so that's quantity demanded. It's the amount of a good that buyers are willing and able to purchase. And it follows this condition. It's called the law of demand. And this is that other things being equal, quantity demanded of a good falls when the price of the good rises. So this is an inverse relationship. Okay? They're opposite. When one goes up, the other goes down. Right? As the other goes down, the one goes up. They operate inversely. That's why the demand curve is negatively sloped. Right? Because when the quantity demanded of a good falls, the price rises. Okay? Or you could say when the quantity demand of a good rises, the price falls. Okay? So let's look at that. Well, in a second, we're going to look at that graphically. So the way we have a demand curve, especially in micro, is we look at a demand schedule. A demand schedule is just simply a table that shows the relationship between the price of a good and the quantity demanded. Okay? And remember, it's an inverse relationship. Think about it. If the price goes up, quantity demand goes down. If the price goes down, quantity demand goes up. Okay? So maybe just pencil that out. You can just write a P with an arrow. So P goes up. So if the price goes up, right, then the quantity demand is going to go down. Obviously, just think about any good that you could isolate. So I don't know, think about, I always gravitate to like beer or something like that, but think about a hamburger, a Big Mac, right? If the price of Big Macs goes up, you think you'll buy more or less of them, right? You're going to buy less. It's an inverse relationship. Now, on the other hand, if the price of Big Macs goes down, you'll probably buy more of them. Okay, it's an inverse relationship. And a demand schedule shows the different combinations of price and quantity demanded, right, for a particular market. Okay, and that's what a demand curve is. It's derived from the demand schedule. And it's a graph that showcases the relationship between the price of a good and the quantity demanded. Okay, so it looks like this. So here's Catherine's demand schedule and her demand curve. So note that this is the demand schedule, okay? And this over here is the demand curve. So the demand schedule simply tells us that At a price of 0, Catherine will demand 12 ice cream cones. If the price goes from, so this would be a marginal change from 0 to 50 cents, right, incremental, then she demands less. Okay, notice how this is an inverse relationship. Okay. Notice the price goes up from 50 cents to $1 for an ice cream cone. Well, she demands even less. Okay, this is similar to our example last class when we looked at Emma's novels. Okay, so as the price goes up, quantity demand goes down. Okay, so this is the demand schedule. It's all the different combinations of price and quantity demand. Now this is for just one person. And we can graph that, right? This is using that Cartesian coordinate system. So you have a y-axis and an x-axis. So we always put price on the vertical and quantity on the horizontal, okay? And what this graph shows us is that the demand curve is negatively sloped. It's sloped downward, okay? It shows you that if, for example, at this price here, quantity demand is 0. So if the price of ice creams is $3, quantity demand is 0. If ice creams are free, Catherine will demand 12. Okay? And then every point along this curve is just a different price and quantity demand trade-off. Okay, so the big takeaway here is as price goes down, quantity goes up. Okay, pretty straightforward. Now we have something called the market demand. So obviously that's just for one good and one person. Okay, so that's Kathy's demand schedule. But let's just think about a small town or something like that. So there's not just Kathy. There's probably maybe, hundreds of people who might be willing to purchase ice cream, who would be in the market for ice cream. So the next sort of phase or iteration layer to that analysis would be, let's add another person. So now we have Nicholas. Prices don't change. So we still have a demand schedule, which is predicated on the price. So at a price of 0, Catherine would demand 12, but Nicholas would demand 7. So you get 19. Again, this is a simplification, right? This is just meant to be a teaching tool. Like obviously if the price was 0, they would take all of the ice cream. Like it's free, presumably. Or let's say it wasn't a market for ice cream cones. This was a market for cell phones, right? So at the price of 0, like a rational person would take all of them, right? But we have to operate in this way. So we say if the price is 0, Catherine's demand is 12, Nicholas is 7. So the market is the aggregate, right? It's the summation of the two curves. So 12 plus 7 gives you 19. Okay, and similarly, as the price goes from 0 to 50 cents, Catherine demands less. So does Nicholas. Notice he went from 7 to 6. But there's a market demand curve, right? Which is just simply the summation of individual demand curves, right? It's the aggregate. So, I mean, we could keep on adding people, right? We could add dozens of people, and it would just simply be their individual demand schedules added together. Okay, so the way you graph that is by simply merging the graphs. So you add Catherine's demand to Nicholas's demand. Notice the price hasn't changed, just the quantity demand the combinations have. Okay, so it's like an average of the two, really. You're adding them together. So you can see at a market price of $2, Nicholas has a demand of 3, and at a market price of $2, Catherine has a demand of 4. So the market demand is $2, that's the price, and the market demand is 7, right? 3 plus 4. Okay? So we're still graphing price on the vertical and quantity on the horizontal. Okay? So I hope that makes sense. So that's the market demand, and it's just the sum of individual demands. Okay. Now, we can move and manipulate that curve. So any change that increases the quantity demanded at every price is going to shift the demand curve to the right, right? So the key word was any change that increases the quantity demand. It's going to shift the curve to the right. So increase in quantity demand shifts the curve to the right. And that's called an increase in demand. And then correspondingly, any change that reduces the quantity demand, so keyword being reduce, shifts the demand curve to the left. Okay? So let's look at an application of that. So again, here's a demand curve. Let's just say this is the market demand for ice cream. Okay, so it comes from this graph here. Let's say this is the market demand for ice cream. So that's this blue curve. And we're saying we can actually shift that curve to the right or to the left. Okay, we can shift it to the right or to the left. And that shift shows you the change in quantity demand at the same price. So if the price was, let's say, if this was 2 down here, so at 2 quantity demand is here, but at the same price, something could cause the quantity demand to change at that price. If it went up, it would shift the curve this way. So this would be an increase in quantity demand at that price. Or it could go to the left, which would mean something changed the quantity demand at every price to a lower amount. Okay, so we can, the big thing to note is we can move this curve. It's not static. So if you think about the logic here, what we're doing is we're building the curve first. We're saying, okay, this curve comes from individual demand curves, which are added together, right? So we've got like this market demand. So it's everybody who's in the market for demand. We recognize each and every one of those individuals has a specific demand schedule, but we merge them all together, right? We get a market demand, and that's what this curve represents. But we're saying something could cause that whole curve to shift to the left or to the right. If it shifts to the right, it means if you hold price constant, quantity demand has gone up at the same price, right? So something exogenous to the model could cause us to increase our quantity demand for that good at the same price. Or something could happen that would cause us to shift our quantity demand to the left at the same price, right? So what can do that? So some factors that shift the demand curve. Well, the first thing you need to note is whether or not the good in analysis, right? So the good in particular. So again, we're taking baby steps. We're just looking at one good at a time. We're just looking at demand for apples, or you could say oranges, whatever. Demand for, you're just looking at one good. Now, if that good is normal, okay, and most goods are considered normal, if our income changes, okay, so income would be an exogenous change. It's something outside of the model. That's the best way to understand it. So here's the model. The only two things that we're looking at are price and quantity. So it's the market for ice cream. So you have the price of ice cream and the quantity of ice cream. The only way this curve shifts is if something outside of a price change occurs. Okay, if it's just a price change, it's movement along the curve. So something outside of this. So basically anything other than a price change could cause the market to shift. So one of those things could be income. So if your income changes, it'll affect your quantity demand for this good that in particular that we're looking at. If it's a normal good, right? So this is a good for which other things equal, an increase in income leads you to buy more of it. Okay? That's a normal good. That means, okay, you like wine? All right. Well, let's say I give you a $10,000 raise. Are you going to buy more wine or less wine? Right? If you like wine. Or let's stick with Big Macs, right? It's an easy one. If you like Big Macs, yeah. If you got a $10,000 raise, do you think you'll buy more Big Macs or less Big Macs? If Big Macs are a normal good, it means you'll probably buy more of them. Okay? Now, an inferior good is one in which other things equal. If you get an increase in income, this leads to a decrease in demand. Okay, so in our case, if we're looking at the market for Big Macs, If you get an increase in income, you'll probably buy more. In fact, we could just look at the model for the market for ice cream. Ice cream is really a normal good. If I earn more money, I'll probably buy more ice cream. If I earn less money, I'll probably buy less ice cream. So if we were doing the market for Big Macs, we would just change this, right? Price of Big Macs. We could say if I earn more money, I'll buy more Big Macs. If I earn less money, I'll probably buy less. But then we have these goods that are known as inferior goods. Okay, and they follow the opposite logic. And that would be a good, like, the best example I can think of is Kraft Dinner or Mr. Noodles or some inferior good. It means if you earn more income, you actually buy less of it because it's inferior. You were buying it because your income was so low. But as you earn more money, you don't buy it anymore. So it's the opposite of a normal good. So that would be an inferior good. Okay? So like Kraft Dinner, Mr. Noodles, any like really cheap. Like I don't think Big Macs are inferior because it's a really good sandwich, but maybe like the amount of time you go into the dollar store, like the things you buy at a dollar store, as you earn more money, you're probably less likely to buy those things. They're really inferior goods. Okay, that's I think the best way to think about it. Okay. Now, another thing that can cause the demand curve to shift would be the prices of related goods. So these would be like, think about substitute goods. So goods that can stand in for each other. So the best example of a substitute good would be, let's say, honey and sugar. Okay, these would be substitute goods because if the price of honey goes way up, then the demand for sugar, will go up. So if the price of one goes up, the demand for the other goes up. These would be substitutes. Because, or think about milk and cream, right? Let's think about like coffee, for example. Let's say the price of cream goes really high. Well, then you'll be more likely to put milk in your coffee because you're not going to spend a ton of money on cream. You'll be like, well, I'm not going to spend that. I'll just use milk. So the demand for milk would go up. Okay. Or maybe think about pancakes. Okay. Butter and margarine, substitute goods for some people. If the price of butter goes bananas, like really high, then people are going to buy more margarine, right? So if the demand for one good goes up, if the price of one good goes up, the quantity demand of the substitute increases. Okay. So I hope that's pretty intuitive. Now, so that would mean, so we would shift the curve. Okay, so let's say this is the market for, so we're looking at pancakes and it's the market for margarine. And then we said, so this is the price of margarine. And we said, oh, the price of butter tripled. What do you think is going to happen to the quantity demand of margarine? Well, it's going to shift to the right because margarine and butter are substitute goods. Right? If the price of butter goes up, then the quantity demand of margarine would shift to the right. Okay? Or obviously you could do the opposite. Okay? And then finally you have what's known as complement goods. So these are goods that complement for one another. So it's when it's the increase in the price of one leads to the decrease in demand for another. So let's look at baseballs and baseball gloves. Right? They complement each other. If the price of baseball gloves goes sky high, then what do you think is going to happen to the quantity demand for baseballs? It's going to go down, right? They're complements. You use them together. Okay, so in that case, let's go back to this diagram. This is the market for baseballs. Baseballs. So price of baseballs and quantity demand of baseballs. Quantity of baseballs. If the price of baseball gloves goes way up, then that would shift our demand for baseballs way down, right? Because you need both. So if the price of one goes sky high, it's going to have a negative effect on the quantity demanded for the other. Okay? So that should make sense. So there are things that can shift this curve, namely income, and that would depend on whether the good is a normal or inferior good. Other things can shift the demand curve, which would be the price of related goods, and that would be predicated on whether or not they are substitutes or complements. Okay. Some other things that can shift the demand curve would be tastes. So kind of like something that's in vogue or trendy, the demand for it goes up. Like if I don't know who's like a big celebrity. If Jennifer Lopez buys a particular dress and it's looked positively in the media and everybody's fawning over it, the demand for that dress will likely go up, right? Quantity demand will go up at that same price. So it would shift quantity demand to the right. So this would be like taste, preference, something that's in vogue or trendy. That can affect the demand, right? It can shift it. Okay. Expectations can also shift the demand curve. If you expect something to occur in the near future, you might be more likely to demand it. So let's say you think there's going to be a really cold and snowy fall in Ontario, southern Ontario. Well, that might affect the quantity demand of snow shovels, right? If the price of snow shovels doesn't change, right? Or not to say the price of snow shovels doesn't change, but the quantity demand of snow shovels can shift to the right. So that means the quantity demanded at all different combinations of price has gone to the right. Okay, and expectations would cause that. There would be an increase in quantity demand for snow shovels if we were having a forecast of snow next week. And then obviously the number of buyers can too affect quantity demand, because if there are more buyers, then that means you can shift the curve to the right. There's more quantity demand. Okay? So these are all things that can shift quantity demand. The one takeaway, right, would be movement along the demand curve. So if it's just a change in price, if I said, well, if the price of snow shovels went down tomorrow, do you think more people would buy them or less? And you say, well, more people would. Yeah, obviously. But that would just be, or sorry, opposite. If the let me say this again. If the price of snow shovels went up, okay, so they were $10, now they're $20. Do you think more or less people would want to buy snow shovels? Well, follow the law of demand. If the price goes up, quantity demand goes down. So that's just movement along the demand curve. That is not a change. It's when something exogenous to that model happens, so like a change in income or a change in the price of another good, that could cause you to shift your demand curve. Or similarly, taste, expectations, or number of buyers. So these are, but all of these are not movements along the curve. Movements along the curve are just changes in price, right? This is something that's outside of that model, because a change in price is included in the model. That's basically what it's modeling. So these are all exogenous changes, or something occurring outside of the model. Okay? So let's do a couple of examples, make sure that this is sinking in. So let's look at some shifts in the demand curve versus movements along the demand curve. All right, so let's say so let's start looking at the box here. There's a policy to discourage smoking. So first of all, if there's a policy to discourage smoking, that should have the effect of reducing the number of cigarettes smoked per day. So let's say the government said, I don't want to just use the example of a tax, but let's say the government said, if you buy a pack of cigarettes, you owe the community an hour of voluntary service, right? Some kind of policy. You want to buy a pack of cigarettes, sure, no problem, but you owe an hour of like voluntary service to the community. So you got to pick up garbage for an hour. Well, what do you think that would happen to the quantity demand for cigarettes? Well, it would shift it to the left, right? So that would shift quantity demand to the left, and that's what we're doing here. Now, what about if the government just said, you know what? we're just going to raise the price of a pack of cigarettes. We're going to double it. What do you think the change in quantity demand would be? Well, you would know it. Okay, so this here this would be, you would really call this ambiguous. You don't know exactly how much it would go down by. We're just modeling it, so we're saying it went from 10 or 20 to 10. But movement along the demand curve is really quantifiable. It's not ambiguous. It's actually, you're just following the curve. So if you raise the dollar, or you raise the price by $5, well then you know exactly what the change in quantity demand is right here. Boom. If you double the price, well, it's a change in quantity demand by 8, right? From 20 to 12. So this is an example of movement along the curve, okay, versus a shift in the curve. Again, a tax is basically just raising the price. So that's, the price is in this model. This is mapping the price. So it shows you movement along the curve versus a policy. Nowhere in this model does it say policy discourage, right? That's exogenous. That's something happening outside of the model. A policy to discourage smoking. Well, that's going to shift the curve to the left. Okay? So that's a shift in the curve versus movement along the curve. Okay, I hope that is clear. Okay, so let's do a few more examples here. So you can draw this out, like sketch it out if you got a piece of paper. Just sketch out a graph with a price and a quantity on the axis. And you can label this graph, this is the market for music downloads. Okay, so this is something a little bit intangible. Music downloads. Let's see what happens to the market for music downloads. So you've got a price axis and you've got a quantity axis. So let's just draw in a demand curve, right? And you know your demand curve is negatively sloping. It's sloped down. So you could just draw that in, right? This is just a sketch. So what would happen to the demand curve, right? So now you've got a demand curve. If the price of iPods falls. Okay, so you can pick any price, right? So if you have this demand curve, you draw it, you can pick any price, right? Here, here, here. We'll just pick here, P1. This is arbitrary. Just picking this price, and you have this quantity, because that's what this curve maps out. And we said the price of iPods falls. Like, what do you think will happen to music downloads? Well, aren't these complementary goods? I mean, don't you need an iPod to download music? So if the price of iPods falls, well then more people are going to buy iPods. And what do they do with their iPods? Well, they're going to download more music, right? It's kind of straightforward. So a fall in the price of iPods shifts the demand curve for music downloads to the right. It shifts it to the right. Okay, so now you have a shift in demand to here. So that's what this green line represents. Okay. Now, let's say the price of music downloads falls. So the key thing is it's telling you the price of music downloads falls. Well, okay, I know exactly what happens when the price falls. If I pick this arbitrary P1, if the price goes down, well then I know the quantity demanded goes up. This follows the law of demand. So this would be movement along the curve, right? You could say upward or downward, but this would be downward. So a downward movement along the curve. Okay. Or let's move the curve the other way. Let's say the price of CDs falls. Okay, so this, even though this is 2020, not too many people buy CDs, right? I think like vinyl is probably a little more trendy, but not a lot of people are buying CDs. But those who do, if the price of CDs fall, like what do you think will happen to the market for music downloads? Okay, well, I mean, let's try and put this in context. So I have iTunes, and occasionally I'll download an album, but it's not free, right? It goes right to my credit card. And maybe an album is $5 on iTunes. I haven't bought one in a while, so that could be way off. But if the price of CDs falls significantly so that, you know, CDs are now, you can buy the new like Drake album for $1, well, I'll probably actually not download that album and maybe buy it, right? I wouldn't have anywhere to play it because any new cars don't even come with CD players, but I think like you get the idea, right? These are substitute goods. So if the price of one falls or the price of CDs falls, then it's going to have a lessening demand for music downloads because more people are buying CDs. Okay, they substitute. They technically stand in for each other. I mean, if the end game is just to be able to listen to the album, if there are two options, download it or buy a CD, if the price of CDs falls, then that changes the quantity demand for downloads and it shifts it to the left because you can substitute and buy CDs. Okay, so I hope that makes sense. Now this is probably where I will finish up in lecture tomorrow, I think, because I'm just over an hour, more than an hour. So somewhere around here. So we're going to switch gears. And I want you to just give me a little break. I'm going to get a drink. I'm getting thirsty. Okay. So now we're going to talk about kind of the other side of the coin, supply, right? So these are two sides of the same coin. We're talking about like the market, right? Or a perfectly competitive market or some example of that. And now we're going to look at supply. But since we know what demand is, this will be a little easier, I think, to grasp because it's the same thing, but rather than it being a negatively sloped curve, it is a positively sloped curve. Okay, which means as one goes up, so too does the other. If price goes up, quantity supply goes up. If price goes down, quantity demand goes down. They move together in tandem. Okay, so they move in the same direction. So it's the opposite of demand. And again, I think demand is a little more intuitive because we all are demanders, right? We all demand or have a demand for goods and services, right? Like I get my hair cut typically, right? If we aren't in COVID, once a month. So that's my market demand. And that might change if the price changes. I might get more haircuts or less haircuts, but there's a market that exists for getting a haircut, and I am part of that. Okay, and so I understand like I could plot out my demand schedule for haircuts, or I'm sure if you buy, like vinyl records. If vinyl records are really expensive, you probably buy fewer, and if they're really cheap, you probably buy more. And you could map that out. Like intuitively, you could say, like at these prices, this would be my quantity demand. Very few of us are actually supplying something, right? So it's not as practical. But it's the amount of a good that sellers are willing and able to sell, right? That's quantity supply. How much are you willing and able to sell? And this follows the law of supply. So this is the claim that other things being equal, the quantity supplied of a good goes up when the price of the good rises. In other words, if you're supplying the good, let's say you are supplying let's say it's a barbecue and you're supplying hamburgers. Okay. Do you think you will sell or supply more burgers if the price of them is higher or less? Okay, so let's say the price is 25 cents. You're going to get 25 cents a burger. Okay, this is your market. How many are you going to be willing to sell at 25 cents? Probably none, to be honest, because it probably costs more than 25 cents to make. So let's say the price goes up to $3. So maybe you'll sell a couple, right? It's not really worth your while, but you could sell a couple and do a little bit. As that price goes up, let's say I offer you $100 a hamburger, or let's say the market price gets up to $100 a hamburger, in all things equal, right? So holding everything else constant. That's an important qualifier here. It's HEE, or sorry, HEC, everything else constant. Ceteris paribus, which is the Greek phrase for all things the same. If the price of hamburgers is $100, I'll supply an unlimited amount, right? Because I make tons of money. So from the supplier's perspective, as the price goes up, they're willing to supply more, and as the price goes down, they're willing to supply less. Okay? So this, I think we can go through a little bit faster because it's the opposite. Just give me 1 second. Hello? Oh, hi, Larry. It's Jeff Black. Stephen Clover. You want to go up there? Oh, okay. No problem. So he's there. Okay, no problem. Thanks. You too, John. Oh, sorry about that, guys. I had one of my kids was upstairs. Something was going on. Okay, so we can do the same thing with the supply schedule that we did with the demand schedule, and that is we can map it out graphically and look at it in a table format. So let's do that here. Same idea, right? We're going to look at the market for ice cream cones, and instead of looking at it from a consumer's perspective or the demand side, we're going to look at it from the producer's perspective or the supply side. We still have a price, okay? So price is that unifier. That's what both forces operate under. And at a price of $0, clearly, the firm is going to supply 0 ice cream cones. As that price goes up from 0 to 50 cents, there's still 0 supply. So this is Ben's supply, right? So this is one supplier, Ben. At a price of 0, he's willing to supply 0 ice creams. At 50 cents, still 0. It's not enough for him. At $1, he'll supply 1. At $1.50, he'll supply 2, and so on. So notice, though, that as the price goes up, quantity supply goes up. So this is what I meant by a positive relationship. So you end up with a positively sloped curve. So price of 0 is 0 is supplied. A price of 50, still 0 are supplied. At a price of $1, 1 is supplied. Okay. At a price of $1.50, 2 are supplied. So again, price goes up, quantity supply goes out. Okay. Same graph, right? Price is always on the vertical, quantity is on the horizontal, and this would be quantity supply of ice creams. Okay, so the other graph was quantity demand. Now, there's a market supply, right? So this was just looking at Ben's supply and what Ben would be willing to supply in terms of ice cream to the market at that using that demand schedule. So that's Ben's demand schedule. So that's what he's willing to supply at these prices, this quantity. But of course, we said that in order for the market to be considered competitive, you can't just have one supplier. It can't just be Ben. In order for this to be a market, we need a number of sellers. So let's just add one more, right? Just so that you get the concept. So the same idea. Now we have Jerry, and Jerry has a supply schedule for ice cream cones. Jerry's the same. At 0, obviously he's going to produce 0 or supply 0. At 50 cents, still not enough for Jerry. He's not going to supply any ice cream at 50 cents. In fact, even at $1, Jerry is not willing to supply any ice cream. But Ben is. So there's still a market supply of 1 if the price is $1. Now, if the price goes up from $1 to $1.50, Ben is willing to supply 2, and Jerry is willing to supply 2. So you get a market, okay, or a sum of 4, okay, and then so on. As the price goes up, the market supply increases, okay. So we can graph that. We had Ben's supply, and now Jerry's supply. So we just add those together, and we could say, if the market price is 2, Ben's willing to supply 3 ice cream cones, and at a price of 2, Jerry's willing to supply 4. So the market supply at a price of $2 is 7, right? 4 plus 3. So we get this market supply curve. And of course, it's not limited to 2 suppliers. You want many suppliers and many buyers. There would be Ben, Jerry, and all the other firms that supply ice cream. So there'd be a Chapman and Haagen-Dazs and all the like. Okay, so then you'd get the market supply. Okay, and the big thing to note is that that curve is positively sloped. It goes the other way. So we can also shift the supply curve. Okay, and that would be any change that increases the quantity supplied at every price shifts the supply curve to the right, right? And this would be an increase in supply. So it's something that can increase the supply. So again, this would be something exogenous to the model, because we didn't say, like, we know what happens when you change the price. We know that you increase, or depending on the direction of the price change. If the price goes up, well, then we know that the quantity supply goes up. We know that. That's in the model already. But we can shift the curve. So not movement along the curve, but we can actually shift the curve. And any change that increases the quantity supplied at every price, so if we shift that curve, it's called an increase in supply. And then alternatively, any change that reduces the quantity supply at every price shifts the supply curve to the left. And it's called a decrease in supply. Okay? Same as the demand. But there's fewer things that can shift the supply curve than the demand curve. So again, it's same diagram, right? You shift the supply curve to the left. This is a decrease in the supply. So anything that causes the supply curve to shift to the left, or all quantity supplied at the same prices, would be a decrease in supply. Or you could increase the supply, which would mean at the same price points, quantity supply has increased all across the whole market-wide. Okay, so a decrease is a shift to the left, an increase is the shift to the right. Again, this is a really simplified model. We don't even have any numbers. We're just trying to enlighten you with the illustration. You don't really need numbers. It's more just like, which direction does the line move, okay, at this point. So an increase in supply would cause the line to move this way. A decrease would cause the supply curve to shift that way. Okay, now, what are some factors that can cause it to shift? So obviously, input prices, because you're producing something. So if the price of sugar, or let's say the price of cream went really high, well then suppliers would be willing to supply less at all the same prices, right? Like if the price of an ice cream was $2, and then the price of cream went really high, and because you need cream to make ice cream, then you'd be willing to supply less at $2, right? And at every other price point that you previously were willing to, the whole curve would shift to the left. The only way you can really shift the supply curve to the right is through a technological innovation or development. So if you can somehow produce more for the same prices, like if you, let's say you have an assembly line, you're producing cars, so that's the market. And then there's some new technology that allows you to produce twice as many cars with the same resources as you could before, right? Then your quantity supply would shift to the right. Okay. Expectations, right, can influence your quantity supply, but that would be a short term, and obviously the number of sellers, because that would affect the quantity supply. Okay. Principally, though, these are the two that you want to think about: input prices and a technological change. Okay. All right, where are we at here? So this is just another nice reference page. So if it's just a price change, well, that's just movement along the curve, right? If the price of ice cream goes up, well, then yeah, the quantity demand is going to increase, or sorry, the quantity supply is going to increase, right? Because sellers are making more money. So that's just a movement along the curve, but then these would be shifts. And depending on the nature of this phenomena, this exogenous variable, would cause the curve to shift in a particular direction, depending if it was, like technology would always be a positive. You're not going to have a technological development that reduces your capacity to produce. It's going to always shift it to the right. Okay, input prices, I mean, if the price of cream goes way down, well then, it's not a change in the price for ice cream, it's a change in the price of cream, which would have a corresponding change in the quantity supply of ice cream. So that would be a shift to the right, if that was the case, okay? Because it's an input good, it's not the good itself. Okay, so now comes the harmony, right? This is the marriage of the two. So now that we know about supply and demand separately, we can try and combine them to see how they determine the price and quantity of a good sold in the market. So you have these two forces acting independently. What we're going to do next is we're going to put them together. Okay, so this is pretty cool. When they meet, this is called equilibrium. And this is a situation where the price has reached the level where quantity supply equals quantity demand. Okay, this is an equilibrium. It means it's balanced, right? It's like a teeter-totter. There's not too much of one, like too much weight on one end and not enough on the other. They're weighted equally. They are in harmony, right? They are at equilibrium. It's kind of like the Goldilocks situation. It's not too hot, it's not too cold. It's just right. There's not too much of one and not enough of the other. It's just right. And that's equilibrium. That's when they are the same. Quantity demand is the same as quantity supply. The forces, okay? So what does that really mean? Well, this occurs only at one point on our graph, okay? There's only one point on that graph where they have the same price, where the price for quantity demand is equal to the price for quantity demand. Or sorry, quantity supply. It only happens one time. It's a really special point on the graph. And this is the price that balances quantity supply and quantity demand. Okay, so this is known as equilibrium quantity. So now when you look at that horizontal axis, the x-axis, we're not charting quantity demand or quantity supply. We're charting quantity, capital Q. Okay. Still price on the vertical, but the horizontal now, when we're looking at both curves together, is quantity, capital Q. It's both quantity supply and quantity demand. I'll show you what I mean. It's down here, this quantity, it's still the quantity of ice cream cones, but it's the quantity of both supply and demand. So notice we have our demand curve right here, boom. Negatively sloping, following the law of demand. Then we have our supply curve, bam. And you may ask, how do you get these curves? Well, we have a demand schedule. In fact, we have a market demand schedule. It tells us all the different quantities, whether it's quantity demand or quantity supply, at each price. Okay? So we just plug in the coordinates and we map the curve. That's what we do. Now, there's only one point on this graph where they are the same. Right? If you were to take quantity supply off for a second and just look at the demand curve, okay, you got this point, a price of 2 and a quantity demanded of 7. Okay, and then do the opposite. Now this time take the demand curve off the map and look at the supply and say, okay, when the price is 2, quantity supply is 7. Now let's look at the whole thing. They're the same. At this one point, quantity is 7 and price is 2. It's the same point. Like if you were to map every point of this curve, right, with an x and a y coordinate, you'd have the whole line. And if you did the same for this line, you do the same, x and y coordinates, right? Like a 2 and a 8 and a 3 and a 7 and a 4 and so on. Well, this point here for both lines would have the same coordinates. It's the same, 2 and 7, right? Or it's typically x, y, so 7 and 2. So that's a really interesting point. Every other point in this entire graph, they aren't the same. Only at one singular point. Okay, this is the equilibrium, price, and quantity. Okay, it's pretty neat. Now, to give it some more depth, you're not in equilibrium, right? Those two curves are not in, they're not balanced when you have either a surplus or a shortage. Okay, so a surplus means the quantity supplied is greater than quantity demand. There's way too much of a good and way too little demand for it. A shortage is the other one. It's like, okay, there's way too much demand, but not enough supply. A shortage, like what comes to mind for me, so I don't know if I've mentioned this, but I'm in the hospitality industry. I have a bowling alley and a couple restaurants and things. Right now there is a shortage in labor. So everybody wants to go out for dinner, and everybody wants to sit on the patio, and everybody wants to, get back to normal. So there's a huge demand for hospitality services, but there's a shortage of labor. There's not a lot of people willing to work, right? So the labor market is in disequilibrium. It's not balanced, okay? Graphically, it looks like this. Okay, this is a really cool graph because it tells you so much. Again, let's just start at the beginning. You've got a demand curve and a supply curve, and you know where those come from now. And where they intersect would be the equilibrium, price, and quantity. So we could look at any price that's not $2 and know that it's not equilibrium. They're not the same. It's not equilibrium. So let's go at this price here. Let's look at $2.50. So at $2.50, if you trace across, right, and you see where does that intersect quantity demand? Right here. Okay, boom. Got a quantity demand of 4. All right, so quantity demand is 4. Where does 250 intersect, right? Or the coordinate or the intersection of supply? Boom. Quantity supply at 250 is 10. So notice quantity supply is 10, but quantity demand is 4. There's way too much supplied and not enough demanded. They're not in sync. So this is known as a surplus. There's way too much. Okay? The alternative to that would be a shortage. So let's look at another price that's not $2. It could be any price, but let's look at one that's under $2. So $1.50. Okay, so what's quantity supplied? Right, so now we're hitting the supply curve first. At $1.50, it's pretty low, right? It was lower than, like, they weren't willing to supply very much ice cream, Ben and Jerry, at $1.50. Now, what's the quantity demanded? Well, it's really high because when ice cream is only $1.50, everybody wants it. So quantity demand is 10, quantity supply is 4. There's a shortage. There's not enough ice cream, right? In this market, it's not good. It's not going to last because you're going to have a shortage. There's not enough. So how do we figure out what's the right price for ice cream where there's not too much of it being supplied and not enough demanded, or there's not too much demanded and not enough supply? Well, it's at this one point, this equilibrium point, right? So there's really only three places you can be. You can be in equilibrium, a surplus, or a shortage. Okay? So we now have the law of supply and demand. And this is the claim that price of a good adjusts to bring the quantity supplied and the quantity demanded for that good into balance. So the price is going to keep on, so at this price, it's too high. So then what happens? Well, the price comes down. So, okay, now you're at this supply, right? Sorry, demand. We're looking at the demand curve. So as the price goes down, oh, okay, quantity demand goes up. Price comes down a little bit more, quantity demand goes up a little bit more. Price comes down a little bit more, oh, there, quantity demand's right here. Then you do the same for supply, right? Price, at a price of $2, or $2.50 rather, supply is up here. Willing to supply lots, but as that price comes down, oh, I'm going to supply a little bit less. A little bit less. And those two forces keep on interacting until you get to the equilibrium, or the balance point. And that is the law of supply and demand. Okay, so when we're looking at this model, this market, there's three steps. Okay, this is just basically a review now. Decide whether the event shifts the supply or demand. So I'm going to throw at you events. I'm going to say, okay, imagine you're in the market for ice cream and then this happens. Tell me what happens to the market, right? Infer what's going to change. So that's the first thing, is decide, is it going to affect the supply curve or the demand curve, or sometimes both? Decide what direction the curve's going to shift. Is it going to shift to the right or is it going to shift to the left? And then with that shift, talk to me about the new equilibrium price and quantity. Because if you shift a curve, you're going to shift the equilibrium price and quantity. So let's just do a couple examples. Okay. So here we have the market for ice cream again. So again, price, quantity. We have a demand curve, equilibrium, or sorry, demand schedule, right? Where did this come from? It was our market demand curve, which came from our individual demand schedules. We just add them up, we have this demand curve. Same thing, we got a supply curve. So those blue lines are our original curves. Okay, here is the event. Here's the exogenous change. Hot weather increases the demand for ice cream. So it's kind of obvious what happens here, right? It told you it's, so like, just imagine I didn't write increase the demand for ice cream. I just said the weather is expected to become warmer. What do you think will happen to the market for ice cream? This is where, or why rather, economics is such a practical social science, because it has real life implications. Like, we can actually model this, say, okay, if I expect the weather to be warmer, well then I would anticipate the quantity demand of ice cream to shift. More people are going to want to buy ice cream. Okay, so now you have to take into consideration this increase in demand. So what will that do to the price, right? Obviously, if more people want ice cream now, the quantity demand is shifted to the right, but that's going to change, one, the number of ice cream cones sold, because if more people want it, then there's obviously going to be more sold. But it also, at the same time, will affect the price of it. Okay, so note that if you shift the demand curve to the right, price goes up, so too does quantity. Okay? How about this one? An increase in the price of sugar. What do you think is going to happen? So again, these slides kind of give it away here, but let's suppose it just said there is an increase in the price of sugar. Well, this is an input cost. So do you think this is going to affect the quantity demand or the quantity supply? Okay, so you pick up on the fact that it's going to affect quantity supply, because it's going to affect the suppliers because they have to pay more for sugar. Well, what does that mean? Well, because they have to pay more for sugar, they're going to shift their supply of ice cream to the left. They're going to be willing to supply less of it because of the law of supply. Okay? Because the price of an input cost has gone up, it's costing them more, so they're gonna supply less. Okay? So this would result in a higher price and less being sold, because fewer people are going to buy it at that higher price. But you have a new equilibrium price. This is where what the suppliers are going to be willing to supply at this new amount. Okay, it's less than originally. Okay. Now these graphs here are a little hairy. So this is, we're saying two things happen. So let's just look at, I'm just going to walk through the first one. So this one would be both. So this would be, let me just see here. Yeah. So we're looking at the blue curves, right, to start. Supply and demand, initial equilibrium. So you don't need to have the actual numbers, okay? You just need to know how to manipulate the graph. So let's say I said, not only is it expected that it's going to be warm out tomorrow, like very hot, but also the price of sugar is doubled. Okay, so again, obviously you're not making the ice cream tomorrow, but just say you were. So if it's going to be really hot, okay, boom, I know what that's going to do to my demand curve. It's going to shift it to the right. Okay, so this demand for D1 is going to shift over here to D2. So I got a new equilibrium point. But then I also said, too, that the price of sugar has gone up. So that's an input cost for supply. So that means I'm going to supply less at every price. So that's going to shift to the left. Boom. So now I have this. So the net effect would still be an increase in price and an increase in quantity. Okay. The reason for that is because this shift in the temperature is bigger than the shift in the price of sugar. So these changes they're kind of arbitrary. You don't know the actual magnitude. But in this case, because the temperature change was much greater than, so it's a slight change in the price of sugar, so it's going to shift supply a little bit to the left, but a big change in the temperature, so the net effect would be an increase in quantity, increase in price. Sometimes, okay, so this graph here is the opposite of that. This would be a really big increase in the price of sugar and just a small increase in temperature, let's just say. That's what this would map out. So you could clearly say, well, the price is going to go up, quantity is going to go down. Sometimes what can happen is it's called ambiguous. You don't know. So if you don't know the magnitude of the changes, like sure, you could say if it's going to be hot out, it'll shift quantity demand to the right, but the price of sugar is going to go up, it's going to shift this to the left. But if you don't know the actual amounts, then you say the change would be ambiguous. So Q would be ambiguous because you don't know the change in Q, but the price goes up either way. Okay. Okay, so in conclusion, well, we're not actually quite done yet. Market economies harness the forces of supply and demand to serve that end. It is supply and demand together that determine the prices of an economy's many different goods and services. Prices, in turn, are the signals that allocate resources. Okay, that was kind of like the whole point of this lecture. Now, this is what you got to know how to do. So we're going to do some math here. Okay. This is your quantity demand, and this is on your assignment. So you'll be given a quantity demand, and this is your demand function. This is really the market schedule. And I'll give you that. I'm not going to ask you to derive that yet, right? Maybe by the end of the term. But right now, I'm just going to give this to you. And what it is, it's the blueprint for your demand curve. It tells you the coordinates for the entire curve. If you sub in any value for P, you get the corresponding Q, right? So it's the subscript is demand. So you're really looking at P's and Q's, okay? But the demand is telling you it's for the demand curve. So if you sub in any value for P, like if you sub in a 10 for P, right? So if price is 10, right? If this is 0 and that's 14. If price is 10, well then 4 times 10 is 40. 56 minus 40 is 16. So then if price is 10, quantity is 16. You could sub every price on this axis, you would get the corresponding Q, right? In fact, the easiest thing to do would be to solve for the axis intercepts. In other words, if you sub a 0 in for price, if you put a 0 in, so you say price is 0 down here. Well, what's Q? Well, it's actually 56 because 56 minus 0 is 56. So at a P of 0, price is 0, Q is 56. So you got 1 point. Now, conveniently, what you could do would be, let's sub in a 0 for Q. So what happens when Q is 0? Okay, so now you've got a 0 over here. Well, you're gonna rearrange this, bring that over, so you got plus 4p, and then bring the 4 under, right? 56 divided by 4 gives you, well, whatever it'd be, just, I think is it not given? I mean, if you just get a calculator, I think it's 11.25, I believe. Right? You're just dividing 56 by 4. Yeah, 11.25. Okay. So now you have, no, sorry, it can't be 11.25. Here, we'll look it up. Let's do it. It's got to be more than 14. Okay, so the graph is slightly off. It is exactly 14. This line here should line up with the 14 exactly. Okay, so you could solve for the intercepts. You're just subbing in a 0 for Q, right? And then getting the corresponding price. So it's actually 14. So this should say 14 up here. And, right, so that's saying if quantity is 0, so if Q is 0, P would be 56 divided by 4, which gives you 14. So P would be 14. Or if price is 0, sub a 0 in here, 4 times 0 is 0, 56 minus 0 is 56. So you got it there. So now you got the two endpoints. And all you really need to graph a line are 2 points. This equation, this function, tells you all the other points because you just plot in any value for P and you get the corresponding Q. Right? This is the function. Once you know that, you could calculate the slope, right? And it would just be the change in the rise over the change in the run, right? And I detailed that in my last presentation. That's the definition of slope. It's change in y over change in x. So you need 2 points. So you'd have to, like, really you have to sub in two prices, right? To sub in the prices because they're the easier to solve for. Sub in 2 prices, and then now you've got 2 points on this line. Draw the triangle. The change over the rise over the change in the run gives you the slope. In this case, it's -1/4. Okay, it's negative because it's a demand curve. The change in the rise is always going to be, the change is going to be negative, right? The net change. Okay? It's going to be negative because it's a demand curve. Now, we can do the same for the supply curve, right? So we have a supply function, right? This is the linear curve. And this is the same idea. Let's see if they got it right on this one. So let's say you sub in a 0 for price. What is quantity supply? Okay, so a 0 for price. Oh, they got it right. -4. Right? So the first thing you want to do is plot out the intercept points, -4. Now, what if you put in a 0 for Q? Okay. Well, you could rearrange this a bunch of different ways. You're going to end up with 4 divided by 2. It's 2. So they got this right. So now you have these 2 points. You just graph the line. You could plot any other two prices. So you could put a price of like 4 and get a corresponding Q. And then put another price in at 6, get a corresponding Q. And now you're going to do the same. Change in y over change in x. It's a positive. Right? So the slope is always going to be positive because you're looking at the supply curve. So it's 1/2, right? 2 divided by 4. It's constant. It'll always have that slope. So you've now got a supply and demand curve. How do you solve for this point here, this equilibrium point? How do you get that? Okay, so they got the graph right down here. Now it's at 14. How do you get that point right there? Boom. So you've got the demand curve right here. You got the function for it. So you can just plot in any numbers and you can graph that. Okay. You also can solve for the slope. Then, okay, you got the supply curve. Using this equation, you can plot the supply curve. So now you put them over each other. You got a supply and a demand. I want you to tell me this point. Obviously, you know what it is, but how do you get that? Well, you got to set those two curves equal to each other, because remember, I said there's like only one really special property about that diagram. Where those two curves intersect, the coordinates are the same. So if you want to know the coordinates for that point, just set the two functions equal to each other. So you're going to take your supply curve. Okay, so yeah, they screwed this up. It doesn't matter which one you put first, right? You're setting quantity supply equal to quantity demand, but it's just so you don't get confused. Quantity demand is 56 minus 4p. So this here, they just kind of, these should be inversed. This should be quantity demand, this should be quantity supply to make this make sense. But doesn't matter. You could set quantity demand equal to quantity supply, or quantity supply equal to quantity demand. Same thing. You're setting them equal to each other. So all you're doing is you're collecting terms, right? You're moving this, in this case, they move the plus 2p over here to get a minus 2p. You're taking the 56, bringing it over there to be negative. So you got negative 6p equals negative 60, multiplied by negative 1. Now you got positives, p equals 10. Okay, so that is the equilibrium price, because you set the two curves equal to each other. So p is the same for both, because that's what you're forcing to happen here. You're setting them equal, so you know where, because p is the same for both, it's the only thing you can solve. Now, once you know the price, you can solve for q, because q is the same for both. So it doesn't matter if you sub it into quantity demand. Okay, so if you sub a 10 in for p here, like they just did here, so 56 minus 4p equals 56 minus, it's 40, right? It's 16. Or if you put that 10 into quantity supply, right? 4 plus 2 times 10, so 4 plus 20, negative 4 plus 20, negative 16. So it doesn't matter what equation you put it into, you'll get the equilibrium quantity. Okay, so what you just solve for is this point here. We have an equilibrium price of 10 and an equilibrium quantity of 16. And that's all derived from this market supply and market demand curve. Okay, so I will give you these curves, but I just want you to know where they come from. Okay. All right, that's it. Assignment 3 is on Sakai. I showed it to you at the beginning of this video. The last two questions are modeled after the equilibrium price and quantity. This is like one of those like greatest hits for both micro and macroeconomics. You need to know how to solve for the equilibrium price and quantity. Okay. Next week, when we get into elasticity, it's quite a bit more micro-oriented. So this is the last lecture where they kind of overlap, right? So going forward, it'll be like elasticity is exclusive to micro. You wouldn't learn about elasticity in macro, but in both micro and macro, you do need to cover the fundamentals for market supply and demand. So I really hope that this made sense. This is all we got to cover for this week, okay? Just gonna go back up to the top. But if you are struggling with this, so I really designed the class to start out slow. We're only covering one chapter a week right now. Like last week, you know, we did we did chapters 1 through 3, but we talked about thinking as an economist, and then you know, the 10 fundamental principles, and then the gains from trade. We wrapped that all up into one package. This week, all we're doing is chapter 4. Next week, all we're going to do is chapter 5, and then the following week, we're going to do chapter 6 in one sitting, and then you'll have your midterm. When we get back from the break, it's going to be chapter. Every lecture is going to be a full chapter. So I would do all of this in one chapter. So you would basically, we would do this for Monday, and then a whole other chapter for Thursday. My reasoning for that, obviously, is because of the COVID regulations and the fact that a lot of students can't be in person, and since this class is blended, they would just basically be missing out on the one that they couldn't be in person for. So otherwise I would have to do an online video as well as an in-person lecture for every single chapter. So I kind of dodged that bullet by just getting us to do one chapter a week for the first half of the class. So long story short, I hope you're keeping up, but it's gonna pick up a little bit. Like, we're gonna double up on the amount of content you're gonna have to know per week. Okay. All right. So hopefully I can catch you guys tomorrow. I'm gonna upload this video this evening so that you know it's there in case you have a hard time getting on campus. I don't know. I got an email today stating that, like, if you're only single vaxxed, you have to be tested, and they might be like setting up some kind of police mechanism for that to make sure. So I could see it being maybe a little bit more delayed tomorrow than it was last Monday, but who knows? Time will tell. In any event, all the content for Chapter 4 is now available on Sakai. That's all we need to do for this week. Chapter 3 is there. I hope you enjoy your tutorials. Try and get the most out of tutorial. Ask your TAs a bazillion questions. That's what they're there for. Okay. So until next time, thanks for your attention. I'll see you tomorrow. Be good.